Good morning, everyone. What we're going to do today is be talking about the part 2 of the 3.1 lesson, and we're going to be solving a system using substitution. Okay. Just kind of clarify, in the last video, we talked about how we were going to solve a system using graphing. Okay. That would be done by taking two different coordinates or two different lines, linear equations, graphing them out, and seeing what coordinate they both cross at. Okay. We also talked about how that method works out very well. If you're given pretty nice equations that do cross at a whole number. Unfortunately, that only works in certain situations. In other situations, it doesn't work, okay? We also talked about in that video where if we get decimals as an answer, if we're graphing, we're going to be guessing, okay? And we don't want to be guessing. We want to be getting exact answers. So today is going to be the part 2 of a 3-part lesson where we're going to talk about kind of the next step in these problems, okay? What we're going to do is solve a system with a method called substitution, okay? So just kind of quickly cover a couple of things. So first and foremost, substitution is the method today, and we do have an example in the book. However, I'm going to be going through 2 separate problems with you in this actual video. We're going to talk about A and B, okay? We're going to talk about how we actually solve out a system like this using a substitution method, okay? So let's go ahead and get into it. First and foremost, let's talk about letter A, okay? Now, the whole idea here is when I'm ever using the substitution method, I basically want to replace. So I'm going to use the first equation to replace something in the second equation, okay? And I'll just kind of label these as first and second. So I want to use the first equation to actually replace something within the second equation, okay? Now, the first one is going to be pretty straightforward because it's already given to us in this form. But the one thing I want you to notice is that, you notice how the first one, they give us an x equals portion, right? So they're basically telling us that x is equal to this whole value right here, okay? Well, all the substitution method really means is that I'm going to take that whole value in red there, okay? I'm going to take this whole value and I'm going to actually plug it in for where I have an x in the second equation. So what I'm going to do is actually take that value and plug it in for that x, okay? I'm allowed to do this because both of these values have an x in it, right? So I can replace the second x with the 25 minus 3y, okay? So what this will give me is 25 minus 3y plus 5y equals 9, okay? Notice once more how all I did was take this value here and plug it in for that x, okay? That's how I got this value down here. Once I take this step, if you notice, now I have an equation. Rewrite that. Now I have an equation in which all I have is a single variable. Instead of having 2 variables on the top, I have a single variable for each of these. So what I'm allowed to do now is start to solve this out and actually get an answer for y. We're going to distribute the 4 throughout the parentheses. This becomes 100 minus 12y plus 5y equals 9. From there, we just need to simplify. The 5 and the 12y are going to simplify to 100 minus 7y equals 9. From there, we're going to subtract the 100 over. We have a positive 100 here, so we're going to subtract it over to the other side. This would give me negative 7y is equal to negative 91. And then for our last step, all we have to do is get rid of that negative 7. We can do this using division. Divide by negative 7. This would give me y equals, and then 91 divided by 7. Let's go ahead and grab our calculators. 91 divided by 7 is going to give me an answer of 13. So if you notice, we actually were able to get our answer for y. The whole idea here, once again, is that we're going to substitute a portion of the equation in, as we did up here, and then once we take that step, we can actually solve it out. Now, in these problems, we're going to want an answer for both x and y. So notice how we have y over here to the right. What we still want to do is try to figure out how do we find x. Well, here's the beauty of it. We know what y is equal to, right? We know that y is equal to 13. So what we can do now is take that 13 value and plug it in to this equation up here. So let's go ahead and do that. We can take the original equation, which was x equals 25 minus 3 times y, and plug 13 in for that. And if you notice, we have an equation in which all we have to do is solve out and get an x. This would be x equals 25 minus 39, or x equals negative 14. And by using that method, we were given both a y answer and a x value. Okay? Once again, this method is pretty straightforward in the fact that once you substitute one of the top equations in, or either the top or the bottom equation, once you substitute a value in, then you should be able to work it out and actually plot different values in to actually get to your final answer. Okay? So then let's talk about a little bit of a different problem here. Okay? Let's talk about a little bit different problem. So now, in the second one here, I'm given a little bit of a problem, right? I got to try to figure out a way to substitute. All right? Now, I'm really not given an x or a y by itself. Okay? I'm really not given a value that's simply a 2y or anything like that. Okay? So I want to try to figure out how can I actually substitute this value in. Well, we can try to play around with this to actually make our lives a little bit easier. Okay? And here's what I mean by that. First and foremost, when I look at this problem, I want to try to find a common piece between the top and the bottom. Okay? Well, the first common piece I see is they both have an x and a y. Awesome. Unfortunately, if I want to have that, I need to either have an x and a y by itself on top or on bottom. On bottom here, I technically have a y by itself, but I got a 2 in front of it. So I'm trying to think, like, how would I get rid of that? How would I actually affect that value? Well, in this specific one, we want to try to think of an easy way to actually plug this into the other equation. Well, do you notice how we have a 2y here and a 2y here? Well, technically, because these are the same thing, what I can do is take what they're equal to and plug it in. So because it's equal to x minus 10, I can actually plug that value in for this 2y. Because 2y equals this. Okay? That would give me the equation on top of x plus x minus 10 equals 14. Okay? So all I did was take this value here, the x minus 10, and plug it in for 2y. Because they're both equal to 2y. At that point, I can just simplify. This would become 2x minus 10 equals 14. Add the 10 over to get 2x equals 24. And then divide by the 2 to get x equals 12. Okay? And then once I have one value, I can just plug it in to find the second. We'll go ahead and use the bottom equation. So we have 2y equals x, which we know is 12 minus 10. This becomes 2y equals 2. Divide out that 2 to get y equals 1. And just like that, we have our answers for both x and y. Okay. Once again, we did this by just substituting in a similar value into the other one. But before we go on there, let's kind of talk about a different situation. Let's say we have a problem where we're not given a good substitution. Sometimes you actually have to put a little bit of work in before you can actually solve this out. So we'll go back to the other page and we'll talk about letter C now. Okay. This is kind of the first problem where we're not given a great situation. Okay. In letter C, we have y minus x equals 4. And we have 3x plus y equals 16. Let's fix that plus right there. Well, the first thing I notice here is how, even though I have an x and a y, I don't have a single one by itself. If you notice up here, when we started both of these other two problems, we had an x by itself in the first one and a 2y by itself in the second one. In this problem, I'm not given that. So I can't really substitute right now. I'm kind of struggling in actually doing in the first step. So what I need to do is I need to play around and try to find a way to actually do this. Well, what we can do is we can actually manipulate the actual equations into our favor, okay? What I mean by that is if I look at the top equation, okay? If I look at this top equation, I have y minus x equals 4. Well, if I want to try to get a y or x by itself, couldn't I just take this x and add it to the other side? Wouldn't that give me y equals 4 plus x? Do you see how I can manipulate that problem to get one by itself? So now at this point, I can follow the same steps we had before. A y by itself, and on bottom we have a y by itself. So I can take x plus 4 and plug it in for that value because they equal the same thing. So that would give me 3x plus 4 plus x equals 16. Okay? So by manipulating the top equation, we can actually make the bottom equation a single variable problem. From there, we go ahead and solve this out. We want to combine like terms. 3x plus x would be 4x. 4 can just be rewritten, equals 16. Subtract the 4 to the other side to get 4x equals 12. And then divide out that 4 to get x equals 3. Okay? And that's how we get our first answer. Once again, we want to try to find the y value. So we're going to go back up to the original. And what we're going to do is, since we have an x value, we're going to go ahead and plug it into this problem. We'll go ahead and use the top equation right here to actually plug x back in. This would be y minus 3, because that was our x value, equals 4. We add the 3 over to get y equals 7. And we've solved out that problem, okay? The key thing with substitution, the thing I'll kind of leave on the end part of this lesson, is that we need to be able to get a value by itself. So our goal is always trying to look for something like this, where we have a y or x equal to a specific value. Something like this in letter A, x equals 25 minus 3y. Because once we're given that value, we can actually substitute it in with the other equation. Okay? Go ahead and finish up answering the questions. We'll go over any questions you might have in class the next day. And besides that, you all have a great day. See you tomorrow.